we're going to be talking about another situation with the law of sines, and you guys will figure out pretty quickly that there's a lot more to it. It's not hard though, it's just there's a little more to it. Just to give it one more moment in the classroom, law of sines, matching side and angle. We're not talking about like a match that you strike and have a fire, but if you have a side and an angle that go together, law of sines to the rescue. Okay, and that happens if you have angle side. If you have angle side, like yesterday, the video, you get a match. Now, today we're going to take a look at side angle, and since this is a family program, we'll keep it clean. Make sure we spell it side angle. All right. Now, here's the deal: side angle is going to end up being a little bit more than just plug it in and get an answer. So I need to begin with you guys on talking about the height of a triangle. And it might cross your mind in the next 5 seconds where you're like, why are you doing this? You'll see. So we're going to talk about the height of a triangle. And then, again, we'll be able to use it for this thing called side angle. Just by the way, it doesn't hurt to play along with me here. I mean, you probably want to sketch this, but just at least notice, please notice as you're sketching it that it's side angle. Because sometimes kids are like, what's side angle? Two sides, and an angle. Okay? So that's kind of like what we are given. We're given a side, and an angle. The height of the triangle. Now that you mention it, the height of the triangle. It exists. Maybe we'll call it X. Haven't really used X much lately, so we'll get an X in there. It's probably not a big surprise to you for me to draw your attention to this right triangle and say that it contains the height. In fact, when you really look at that right triangle that I'm highlighting, it actually contains an angle and two sides. Now, one of the sides I want to know, but it's kind of cool. It kind of contains like most of the information. And you know how to solve right triangles. In fact, you know how to, I'll say you should know how to relate these three letters, A, B, and X. Now, did you kind of hear how I said that? Relate A, B, and X. Like, what does that mean? It means to write an equation. What kind of equation relates A, B, and X? I feel like I hear something. Do you hear it? Oh, it was just those guys out in the hall. I thought I heard like the Sokotoa drum though. That's supposed to be a hint. What's Sokotoa? I know it's supposed to be a little funny. Are you laughing behind there? Okay, A for the day. What Sokotoa statement relates those three letters? Just by the way, everybody should be able to answer this. Now, some of you might take a little more time, but if you're kind of just waiting for someone, like you should be thinking to yourself, okay, this is the hypotenuse. Okay, this is the opposite. Well, which trig function uses hypotenuse and opposite? So how does it all go together? It's the sine of equals. Good. You just related those three letters, and I believe everyone in here can do that. Now, maybe you're kind of saying, why are you doing that? Remember, we said we'll show you. But the first answer is because look, the height equals B sine A. That's going to be a big deal. Okay, so let me just say it again. The height equals B sine A. All right, now, today's lesson, you kind of have to almost take the whole thing in before you start to kind of get anxious about anything. And don't get anxious, that's not good. But before you start to say, I know what's going on or I don't, you got to see the whole lesson. So we got this B sine A. The next thing we're going to do is we're going to end up making a chart. Now I'm showing it to you because I want you to just see that it could take up a whole piece of paper. And it's rather complex. In fact, you'll be able to use this chart on a test. So right now, if you select a blank side of your notes, well, you'll be glad you did because you won't have to recopy it for the test. So again, let me say it again. You're going to be able to use this chart on a test. And if you put it in your notes on like a blank piece of paper, in other words, don't put it underneath like all the mysteries of the world. Put it on a blank piece of paper because you'll be able to have that open. You'll be able to have, now you don't have to tear it out because you'll be able to have it open on the test, okay? As long as it's the only thing on that page. Now, I don't make a photocopy of it and hand it out kind of like the periodic table or something because I find that you understand it a little better if we kind of develop it. Okay, so here's the first thing. It's got 2 columns. As maybe you look at what I have up here already, you can see some other things about the chart. Just take a look. It's a side-side angle chart. It's side-side angle. That will mean something to you soon. There's kind of 2 columns, greater than, or check that, less than 90, and then greater than or equal to 90. And that will be angle A, angle A. Now I'm sure you're wondering, so what's this a chart of? So I'll tell you, it's a chart of all the possibilities. If I give you a side, and an angle, what do you mean all the possibilities? You will find out that if I give you a side, and an angle, that it may or may not make a triangle. It may or may not make a triangle. So let's begin, because the more of this you see, the more it starts to come together. So we have like the first possibility. We typically call it no solution, but what it really means is no triangle. What do you mean no triangle? If I give you dimensions such that A is less than B sine A, if I give you dimensions such that A is less than B sine A, it turns out that they would not make a triangle. Okay, now see that B sine A? It's going to show up quite a bit. B sine A is the height. Remember, B sine A is the height. Let's draw a little sketch. Okay, here's a triangle. Kind of looks like the triangle that we started with. You know, it's got angle A, it's got side B, it's got this height. If you can see the colors there, it's green. But look at side A. Don't laugh at it, but it's too short. It's not long enough. Side A is less than B sine A. Okay, now you say, well, make it longer. Well, I can't just change the numbers. So if A is less than this height, you're not going to make a triangle. Okay? Now, it also turns out that you won't make a triangle if A is less than B. That is when you have an angle bigger than 90, when the A is less than B. Check that A is less than or equal to B. We'll put a little equal to in there. Just look at what I'm drawing. I'm drawing a triangle. Well, actually, it's a triangle that doesn't exist because side A is smaller than side B. It would not be long enough to connect the dots to make a triangle. And so that's why that would also be no solution. Let's add a little more to it. One solution means one triangle. It probably would be like what you would imagine if we hadn't even talked about this. That is, you probably would have imagined that you made a triangle. And you do make a triangle if A equals B sine A. If A equals B sine A. A equals B sine A. Well, that means that A equals the height. That means that A is the height. Well, if A is the height, then you actually make a right triangle. And just by the way, did you catch from yesterday's lesson that the law of sines does work for right triangles? Okay, in this situation would be one that kind of shows that. Now there's another one, give myself a little space here. There's actually another sort of category or another way that this can happen. And it would be if A is greater than B sine A. So A is greater than B sine A. And A is greater than B. And A is greater than B. Now, at this point of this chart sort of discussion, it's not uncommon for it to pop in your mind of like, am I going to have to memorize this? Remember, you don't have to memorize this. As a reminder, you will actually be able to use the chart on a test. Okay, I think of it more as something that you need to be able to be able to read, to be able to use, to be able to interpret. So don't get too bogged down with like, oh my gosh, I'm never going to remember. I wouldn't either. I'm looking at it too. Okay, but what you do need to understand is that if A is bigger than side B, well then it's big enough. It makes a triangle. And that's probably what most of you would think would happen had we not talked about this. But again, A might not be big enough. Okay, and then, well, in a moment here, we'll have another scenario. So keep building. Over here, it turns out that if A is greater than B, well, that's all that's needed to be able to make a triangle, to make one solution. Remember, when you're in the right-hand column, the angle A is obtuse. The angle A is greater than 90. All right. Well, you kind of see the pattern here. No solution, one solution, two solutions. Say what? What do you mean two solutions? Well, what I mean is that I could give you a side, and an angle, and it actually could create two different triangles. It could create two different triangles, and that happens if B sine A is less than A is less than B. We usually write that as like a compound inequality. So B sine A is less than A is less than B. That'll work, but let me adjust that just slightly. Okay, it probably feels like that I'm just drawing another triangle. And the truth is, yeah, it's still kind of the common triangle. Okay, it's got the sides, it's got the angle, and it's one of the solutions. It's the second solution that is kind of the intriguing part of today's lesson. All right, I dug around a little bit and I found this felt board. I actually stole it from my wife, but I'm not sure if she used it anymore. Have you ever, told a story on a felt board, put some people up here and tell a story? You guys got to get out a little bit. Come on. We're going to tell a little story. Once upon a time, there was a triangle. Okay. The tape is a triangle that has an angle A. It has a side B. It has a height. Okay. What you kind of want to realize is that stuff is the given. Now it also has a side A. And that side A came along and it said, if you put me right there, you get a triangle. Okay. Now if you're like, yeah, okay, that's the one that I drew. So can you tell the rest of the story? How else can you place side A onto this felt board? And mind you, angle A will not change, side B will not change, the height will not change. Yet you'll get a whole different triangle if you put side A in a new place. Can you tell the rest of the story? I'll let you, like, put the piece of felt on here. So you're going to put side A somewhere else. I'll put it back up here, but it goes somewhere else. And it makes a whole different triangle. Anybody take a stab at it? Sometimes the response you're giving is normal. What if I tell you that it will still connect up here? So now my finger is like a little pivot point. So it's still going to connect up here. Maybe?
So you had it almost like this to create another triangle here.
All right, now, I mean, we're starting to at least think here, which I like. Now, the problem with that is that it requires a different angle A. It's kind of like angle A is not involved anymore.
That's why I was.
It's all right. It gives us like something different to look at, because otherwise we just keep looking at this. Oh. Any other tries? Tell the rest of the story of the triangle. Make sure I'm on the camera here. Can you hold that?
Yeah.
Izzy, can you see? All right, I got it. So look, I'm going to take the side and I'm going to put it right there. You say, well, wait, you changed the triangle. Okay, it's a different triangle, but look, angle A is the same. Side B is the same. Side A is the same. Okay, now the height is still the same, but you kind of have too much tape there. But it's a different triangle, yet it has the same given dimensions. Say that again, it's a different triangle, but it has the same given dimensions. Here, sometimes just with the chalk, it's easier to see what happened because you've seen that now for all the other sketches. Here's the triangle. It's got the same A, B, and A, yet it's a different triangle. And this we commonly call the second solution. All right, and that's the end of that story. Can't happen over here. You can't have two solutions if the angle is greater than 90. All right, well, that's the chart. That's the manual. Maybe you've looked at it, but now it's time to use it. Okay, what we're going to do is we're going to use it to try to solve triangles. Sometimes kids miss this, so I want to make sure you understand that this is still the law of sines. You're going to find out real quick why. But if I give you 3 measurements, and yeah, put this probably on the next page or whatever. Don't put it with that chart, okay, because you just want the chart all by itself. But here's 3 measurements. As you write them down, take a look, because it is the first thing to notice. It's side angle. What does that mean? Well, it means that we need to figure out where we are in this chart, okay, because those 3 numbers could end up in any of those places. Of course, they're only going to end up in one place, so let's start figuring out. We've got an angle. We've got an angle. It's always going to be this way, that it's one angle. Notice that it's less than 90. So now we're in the left-hand side of the chart. Okay, so we're in the left-hand. Now look at the left-hand side a little more closely. Do you see something that keeps popping back up? Do you see, I don't want to call it a formula, but do you see an expression that keeps popping back up? I told you we would need that, okay? So what happens here is you have to find B sine A. You have to find B sine A. When I say find it, you're not going to go look in the desert. You're going to plug some numbers in your calculator. So we've got 10, the sine of 50. Always suggest that you play along on your calculator. Not hard to do, but make sure you understand when we get 7.7, 7.7 is B sine A. I don't really care how many decimals you use because you just need to be aware of its value. Let's dig deeper into this chart. B sine A is always compared with A. Okay, so that's your next order of business. You're going to do some comparing. Looks like A is 14. Okay, 14 is it's bigger than 7, 7. So that means A is bigger than B sine A. By the way, the stuff I'm writing down, ultimately you just need to know how to do. I mean, you can write it down for a problem, for your notes. Ultimately, you need to figure out where we are. Okay, now do you realize we've thrown out one option? Okay, we've thrown out the no solution. But we do have right now A bigger than B sine A. And if you read this correctly, A bigger than B sine A bigger than B sine A. So you see the last comparison, A with B. You're going to compare 14 with 10. And so A is greater than B. And now we can lock into one solution. We can lock into this one. Now, here's what this means. It kind of now means that you have the green light to solve this problem. Okay, when I mean solve this problem, I mean like, think about it as a triangle. Kind of like the lesson yesterday. Okay, but there's actually something a little different about this example than the video that you were to have watched, and you'll find out in a second. But still, we're setting this up, we're solving it. And you jump into the law of sines. Okay, law of sines is nice. Jump in, match 14 with the sine of 50. Jump in 10 with the sine of B. Okay, now this is the part where it's a little different than yesterday because the variable is the angle. But you guys know this is like a proportion. I would suggest that you cross multiply. I will show it the first time. But basically, after you cross multiply, you end up dividing by 14. Okay, so we have the sine of B equaling 10 sine of 50 over 14. Okay, this will be a calculator thing. Make sure that you're aware. Make sure you're aware that we are solving for an angle. And I think a little birdie said, when you're solving for an angle, you want to do the inverse. So if we do 10 sine of 50 divided by 14, we're not done yet because you want to do the inverse of that number. Now, I'm showing you something that some students were never shown before. Maybe you do realize, but most of your calculators have an ANS key. On the TIs, it's on the negative. It's above the negative. What that does is that takes the last answer that you got, 0.54, and it inserts it into that spot. So I can do the inverse of ANS. Again, it's on most TIs, it's second negative. So we are solving for an angle. Angles always use inverse. We get ourselves 33 degrees. Please, if something's popping up and you want to ask about it, just give a holler because we're still solving this triangle. Okay, and the truth is that once you have that angle, once you have 33 degrees, the remaining angle is certainly just a supplement away. So find the rest of the triangle, find 96 degrees. Now, I hope this makes it clear to you that side C is really the only thing left to find. And the cool thing is that I can find it now that I have the angle that goes with it, using, of course, the law of sines. Don't say Pythagorean theorem. Don't say Pythagorean theorem, ouch, right? It's not a right triangle. But you can set up the law of sines. I'll say again, if you want to do it that way, 14 over the sine of 50, c over the sine of 96.83. Okay, and that should kind of feel like the little video that I presented to you to solve that, to basically multiply, get the job done there for side C. I'll show it one time here, but there was just going to be 14, the sine of 96 divided by the sine of 50. Okay, a little cross multiply, a little, not really cross multiply, but just multiply. Solve that proportion, you get 18. Okay, now that was more than one step to solve this triangle. But remember, it all started with deciding what situation we were in. Okay, because it's side-side angle. So it could be any one of those situations. I'm going to give you one to try. Even though we've only done one, I find that if you start just thinking about this, you realize that you can do it. See if you can do it. All right, here's the three numbers. Side A is 3, side B is 10, angle A is 140. Now, I'll just say nicely, because sometimes people are doing this and like you don't need to. If you're finding B sine A, stop. You don't need to find B sine A. Try to figure out why. It has a lot to do with 140. Okay, 140. Come on, solve the triangle. Why is no one doing any work? Solve the triangle. Let's go. I'm kidding a little bit. Okay. You can't solve it. Can't solve it. You should be feeling like that you're in this category. Take a look. 140 was greater than 90. A is less than B. A is less than B. As soon as you get to that, it's a no can do. Okay. 3 is less than 10. A is less than B. No solution. On a test, make sure you say so. Don't just leave it blank. And I realize if you were still thinking that this is new to you guys, but that's all that you have to do for that problem. Okay, let's try another one. $63 degrees. And this pair of numbers, 17 and 18 for side A and B. Now, as your friendly neighborhood teacher, I try to kind of know what's best for you. I try. Looking at the time that we have and kind of knowing where we're at, what's probably going to be best for you here is that we a little more quickly come to a conclusion so that you can realize something. So I'm going to a little more quickly come to a conclusion. That is that B sine A is less than A is less than B. You have to understand that you would have had to think about the numbers. Again, I just kind of saying that because what's best for you guys is that we focus on how to do the two solution. Okay, you're probably not surprised that we are going to do that one. It's kind of the only one that's left to talk about. How do you do a two solution problem? All right, deep breath. I don't think it's going to be as bad as you might think. I don't know what you might think. So here we go. The good news is the first solution is probably the solution you would have came up with had we not even talked about it. What I'm trying to suggest is that it's like the common triangle. It's, you know, everything kind of goes where you think it's supposed to go. And in fact, that's where it does go because that's the given. Side-side angle. And look, this is kind of cool, even though we have to speed up a little bit here. A match. I'm telling you, when you have a match, it's the law of sines. So jump in. Do 17 over the sine of 63. Do 18 over the sine of b. And you want to come to the point that you say, okay, that would be like what we just did for the other problem. Yes, it would be just like what we did for the other problem. And this is where I'm going to give you some answers now. Okay, I'm going to give you some answers because I want to show you how we can go to the next step. So you would solve this, and you get angle B to be about 70.63. Now, once you get angle B to be 70, you would go after angle C and discover that it's apparently 46. I realize you're just writing this down, but realize that you would be going through the same steps that we did in the other problem. So we have these two angles, and then side C, well, that would come out to be 13. Okay, law of sines. Cross multiply, solve the proportion. It's the second solution. Maybe that's why you came to class today, to talk about this second solution. Ready? Now, this still amazes me, even though I teach it over and over, that it's a different triangle, so draw it differently, yet it has the same given dimensions. Okay? Kind of neat. It's a different triangle, but it's got the same given dimensions. Okay? So if we just do the same thing that we did over here, that is, we just kind of match these numbers together, we're going to get the same answer. That'd be silly. We have to do something different. Remember our little story about side A? It's swung over here. It's swung over here. What's true about those two angles? The two pink angles would be the same. So now that angle I just highlighted right there in yellow, that is this angle. And just so you know, it's like what we want to find. It's angle B. We often call it the obtuse angle B. The obtuse angle B. Now, take some time and I want you to sit on this. I hope we get an answer, but let's go back. I drew for you a little different approach to this triangle down here. And I said, or asked, so how big is this yellow angle? In other words, how big is obtuse angle B? Do you see? Okay, it would have something to do with 70. Now you got to realize that 70 is that pink angle that we were talking about. Okay, because this pink angle we were talking about was the original angle B. So it has something to do with 70. And good. Now, I'm going to go ahead and write this as a little formula because people like to have this. It's always 180 minus the acute angle B. Of course, for this problem, that's 180 minus the 70. Put a little box around that, highlight it. It's the obtuse angle B. It's 180 minus the acute angle B. You got to realize the acute angle B was the original angle B. For this problem, it's 70. But that gives us a new angle B. And oh, by the way, it's obtuse. Okay, so it's going to come out like it's supposed to. It's going to come out big. Here's the neat thing. A new angle B gives us a new angle C. A new angle B gives us a new angle C. And that also is going to come out the way it's supposed to, like it's going to be No, small. Okay, always relatively speaking, but it's going to be small. I hope you're adding these numbers and subtracting them from 180 so you can get 7. And then the only other thing that you need to hear after you get 7.6 degrees, 7.6 degrees, oh my gosh, time is standing still. Perfect, because I need like a few more seconds here, is you're going to get a new side C. Now, the new side C is going to come from the law of sines. I don't know if I'll be able to finish this because I don't know when time's going to start again, but the new side C is going to come from doing the law of sines. I just want you to see that we only end up doing it one time. And look, it goes back to the original data, 17 with the sine of 63, but it uses our new angle. Okay, that comes out to be 2. It comes out to be 2.5, but more importantly, you got to see the whole problem worked out. Okay, now there's some homework tonight that like comes out of the regular book. And there's also an assignment